Hello there. Today we'll be studying motion, which involves position and time measurements, which is the basis of the studying of motion. Alright, let's begin. Okay, today we'll be testing a buggy versus a pullback car to see which one has the steadiest motion. Here we go. The car that moves in the steadiest motion would definitely be the buggy. The reason for that would be because it has a constant speed. A rough definition of constant speed is when the ratio of distance traveled compared to time is always constant. This means that an object traveling at a constant speed will cover the same amount of distance in equal time intervals. We planned out our experiment to see whether the speed of the buggy is constant, was that we laid the measuring tape at 8 meters on the ground and labeled the set of 1 meter increments using tape. We would start the car at the end of the measuring tape and someone would time it once the car has been released. Once the buggy passed each increment of tape on the ground, we lapped the time to see how long it would take the car to travel each meter. As you can see here, we made a graph where we put the position of where the buggy was and how much time it took to get to that position. On the left we put position, on the right we put time. And as you can see, here's an example. At 4 meters, it took the buggy 9.05 seconds to travel there. And you can tell that it's fairly constant because the ratio between position over time is very constant throughout the entire table. So you can see that it was traveling at a fairly constant speed.
As you can see here, when we made the graph, we did distance by 1 meter increments and time by seconds. And the points on the graph is the points that we calculated from each 1 meter increment on the cart when it moves. So to calculate the line of best fit, you just take the average of all the points and draw a line through it. And when you want to find the slope, you take 2 points from the line of best fit and use the equation that we will show you.
Since the buggy is at a constant speed, the distance and time graphs would be at a straight line because there's no acceleration or change in speed. Since the equation is speed equals distance over time, and the speed does not change, then the rate of the distance and time will not change. As you can see here, we made a motion dot diagram of our own, and each dot represents 2.25 seconds, and the space between them represents 1 meter, which all totals to 8 meters. To calculate the slope of the line of best fit, we can use the formula that the slope equals to y2 minus y1 over x2 minus x1, which means that we have to use 2 points of the line. Here you can see we selected the points of 8.0, 3.5, and 18.0 and 8.0, and we pretty much did, like, as you can see, 3.5 minus 8 and 8.0 minus 18, and then if you divide those, the slope will equal to 0.45 meters per second. The slope is the speed because the equation for speed is distance over time. As you can see here, we're taking the meters from the y-axis and putting it over the seconds from the x-axis. Here we're predicting distance, and we got a question where it says, explain how you could predict, without using a graph, where the buggy would be after 2 seconds after last measurement. So what we want to do, we're going to use the y equals mx formula, and b, by the way, is implied to be 0 since our speed is 0 when the time begins, therefore the y-intercept will be 0. Now what we want to do, we want to sub values into our y equals mx formula. First we know that the slope is 0.45, and now we want to, and we also know what time would be, and time, by the way, is the x value since it's on the x-axis, and time would be 17.63 because that was our last measure of time, plus 2.0 because we're adding 2 seconds after our last measurement. So then now we want to sub those in. Now we want to find y, which would be equal to the distance because it's on the y-axis, and then we sub 0.45 in for the m, which is a slope, and then we sub 17.63 plus 2 in for x, and then after that we you solve it, and therefore you would find that the distance, which is y, equals to 8.8 meters. So then therefore the buggy would be found at 8.8 meters. There you go, guys. So if you want to find time, you want to solve for time, which is x, you can just sub the distance into y, then sub the slope, which is 0.45, into m, and then rearrange to find x, which would be time. Thank you for viewing our video on the lesson about constant speed. And make sure you do your homework. Bye.